Hello everyone, this is Dipen Shah from Bangladesh and I'm working as junior specialist at Institute of Water Modeling here in Dhaka. And I welcome all of you to the 6th International Hybrid Conference on Water Resources and Wetlands. My research topic is crest level fixation, considering climate change impact using state-of-the-art mathematical modeling, Matraveri Island. And the other co-authors of this research project are Maisha Samia Khan, Mohammad Jafar Islam, Mohammad Opal Mahmoud, Rubayat Alam, and Mohammad Joyrul Haq Khan. This is the presentation outlines, and I'll be discussing about the study area and main problems, then background, and then I will tell you the objectives of my study, and then survey data analysis, and then climate change incorporation, how we incorporate the climate change in our study, and finally how we calculate the design crest level. We'll discuss about. And as you see in the screen, this is our study area. This is Matarbari Island, which is known as polder number 70. There are actually 139 polders all over the coastal area of Bangladesh, and polder 70 is one of them. Polder 70 is under Mashkali Upazila at Cox's Bazar district of Bangladesh, and the total length of the polder is 32 kilometer. And the sea-facing embankment, this is the sea-facing embankment, and it is about 12 kilometer. And sea-facing embankment, erosion, overtopping, waterlogging, and diminishing internal hull drainage capacity are the major problems of the study area. These photos have been captured on the July 19, 2022. As you see in the picture, these are the the present condition of the embankment, and some portion of the embankment are protected by geotube, which are very vulnerable now, and some portion are also protected by block, CC block, as you see in the lower right corner picture. So far in Bangladesh in the coastal zone, actually, from 1960 to 2022, there are several cyclones occurred, and these are the cyclone tracks over the coastal area. So our study area is located somewhere here in this portion, and the 1965, 1983, 1985, and 1991, 2009 cyclones are the main cyclones that went over this study area. In the last cyclone Sitram, there was huge damage in the polder 70. Breaching occurred in this location, and slope failure also occurred. And the geotube that has been placed for the protection of the slope that has also been displaced. And after the cyclone Sitrang, adjacent area was inundated for 2 days. The inundation depth was about 2.5 feet. Now the objective of the study. The main objective of the study is development of storm surge model and wave model for the study area, and to estimate the design crest level for the polder 70 from storm surge model results and wave model results incorporating climate change. For our study, we conducted a primary data collection. These are some pictures that we have taken during our survey program. And the bathymetric survey has been conducted at the sea. This is our Matarbari Island, and this is our main study area. And the west side bathymetric survey have been conducted. Surveys have been conducted, and water level measurement, discharge measurement, and the topographic survey also done for the Matarbari Island. These are the sample of bathymetric data at the west side of Matarbari. These are the bathymetric transit line, and the bathymetric profile in the sea, as you see in the screen, like this. And we have also the embankment long profile. As you see in the graph, the average crest level is now about 5 meter PWD, Meter PWD is the data that is used in Bangladesh, anyways, and the maximum level is 6.5 meter PWD, and the lowest is 3 meter PWD. The condition of the crest level of the present embankment is like that. And the topographic survey has also been done. From topographic survey, we have generated raster land elevation model, uh, which is digital elevation model actually. And about 84% area of Matarbari Island falls under 2.5 meter PWD. So we have also collected the YouTube and CC block information all over the embankment, all through the embankment. About 6.02 kilometer are protected by CC block, and 2.98 kilometer embankment is protected by YouTube. We have incorporated the climate changes to fix the crest level of the embankment. For that, the sea level rise has been taken RCP 8.5 for the year project for the projection of year 2050, and the absolute mean sea level rise is 0.208 meter. From different literature reviews, we have also calculate the increment or increase of cyclonic wind speed due to the climate change, and cyclonic wind speed increased 8% for 2050 according to the IPCC AR5. Though land subsidence is not a part of climate change, we have considered the land subsidence for calculation of crest level of the embankment. We consider the crest level for the eastern hilly region, and actually the study area is located at the eastern hilly region. This portion is eastern hilly region, and it is considered 2 millimeter per year as land subsidence. First of all, we have developed a cyclonic storm surge model. So the storm surge model is a combination of hydrodynamic model and cyclone model. For hydrodynamic model, we provide the bathymetry data, bed resistance, boundary condition as data, and ultimately we get the water level and discharge uh, as a model result. On the other side, from cyclone model is done by the pressure field and cyclonic wind field. During the cyclone, we get the data of cyclonic pressure field and the cyclonic wind speed, etc. From after incorporating into the cyclone model the pressure field and cyclonic wind field, we get the cyclonic model result. So in the left side, as you see in the screen, it is our Bay of Bengal model. For this study, we use a dedicated local model. We cut the model in the study area, covering the sea as well. And we have actually three boundaries in the sea, and an upstream boundary. There is a river that is called Matamuri River, and we provided the upstream boundary. This is the mesh we have used in this dedicated model. Well, actually, in the near the study area, we use very finer mesh, and we updated the bathymetry from bathymetry that we surveyed for the study. And we have calibrated the hydrodynamic model in these three locations, and it has well meshed. And we have also done the validation for the hydrodynamic model in these three locations. We have validated our hydrodynamic model. And this is our 2D hydrodynamic model result, and this is the current speed as you see in the animation. And this is our surface elevation of storm surge model result. One of the model results. Actually, we have simulated 19 cyclone for our study. Now design crest level estimation of the super dike or the embankment. Super dike is called when the elevation is more than 10 meter PWD. We call it super dike. So around the Matrabari boulder, there are 8 points have been selected. Uh, as you see in the screen, M1, M2, M3, M4. For each cyclone simulation, each cyclone simulation, we get the storm surge level, and we have done our analysis. If we make you understood this figure, this is our water level during storm surge, and this is cyclonic wave on top of storm surge. And due to this wave, there will be wave run up on the slope of the embankment. Uh, Crest level will be calculated is equal to storm surge level plus freeboard. Freeboard will come from wave run up. So for all the points for M6, if I say I have already mentioned that we have simulated for 19 severe cyclone, and for each cyclone, we get the storm surge level, and we have done the frequency analysis. For the different return period, we get the different values for the storm surge level. And there are some coastal waypoints. Let's see if I show you M1, M2. These are coastal waypoints. The wave cannot propagate to this point as it is very narrow channel. So in that case, we follow the coastal engineering manual, and using the uh, using the wind speed there and the fetch length, we find the um, significant wave height there and wave period as well. And this is the structure of our wave model. In the wave model, input data is given water level condition, storm surge model result, and the cyclonic wind field. These are the input data, and severe topography also provided. From that, defining the boundary condition, we simulate the model, and ultimately we get the significant wave height, wave period, peak wave period, etc. Uh, for from the model. And this is the animation of a wave model. You see the significant wave height with the time changing, with the wave direction. Uh, by frequency analysis, we also find out the freeboard for every point, M1 to M8, and these are for frequency analysis we have done by Mike Eva. If you see the storm surge calculation for a particular point, as like for M6, the storm surge level is 6.08, and significant wave height for 100-year return period under climate change condition is 3.85 meter. And freeboard considering 5 liter per second per meter overtopping due to wave runoff is 4.3 meter. And the land subsidence are considered as 2 millimeter per year. So for 2050 projection, it will be 0.06 meter for 30 years. Actually, the land subsidence will be like this, and the design crest level is the 6.08 plus 4.30 plus 0.06. That will be our design crest level. And for M6, the design crest level is 10.44 meter PWD. The riverside existing crest level is 3.2 to 6 meter PWD, and design crest level is 6.5 to 7 meter PWD, and the seaside existing crest level is 4 to 5.5 meter PWD, and design crest level is 10.25 to 10.5 meter PWD. Thank you guys. Thank you for your patient hearing.